Hello, welcome to another video with Liah. Today we're going to be talking about stoichiometry. I'm going to be including a few practice problems so that you can see how they are solved. If you're new here, don't forget to subscribe and leave a comment down below. Stoichiometry is basically the relationship between products and reactants, and it also sometimes compares different reactants and different products. Here I have a map. Grams to moles to moles to grams, and this refers to the way you're going to be doing your calculations. So for example, if the problem gives you grams of one species, let's call that A, then if you wanted to find the moles of species B, then you have to convert grams of species A to moles of species A, and then convert moles of species A to moles of species B. So the blue part is of one species and the red part is of another species. So basically what you're doing is just converting between different ones. And to do that, you have to go through this map of grams to moles to moles to grams. You cannot go directly from grams to grams. You must go through moles. And the mole relationships between the two species are taken from the balanced equation, which leads us to the next part, this note here, where I tell you that the equation that you're working with must be balanced in order for the stoichiometric problem to work out. So basically what you're doing is you're reading a question and you're determining what you have. Either you have grams or moles of one species, and then you're determining what you need to convert to, moles or grams of the other species. And if the problem wants you to just go from moles to moles, that you know that all you need to do is look at the balanced equation and make your proportions based on that. In the reaction below, how many moles of butane are needed to make 10 moles of water? And below that we have the equation that we're going to be working with. Now first of all, we need to make sure that our equation is balanced. And in this case, it is not yet balanced. So we need to do that. Alright, so you should have gotten 2 moles of butane plus 13 moles of oxygen gas will yield 8 moles of carbon dioxide and 10 moles of water. Excellent. Okay, so now that we have our balanced equation, we also have the relationships between the different reactants and products. What I mean by that is that if you look here, you can see that 2 moles of butane makes 8 moles of carbon dioxide and 10 moles of water. You can also see that 13 moles of oxygen gas will yield 8 moles of carbon dioxide and 10 moles of water. You can also see that 10 moles of water can be made from 2 moles of butane and 13 moles of oxygen gas. It seems like I'm repeating myself, but sometimes when you're doing these problems, you don't tend to think of it that way. So you want to think about the relationships. What can I make from a given amount? And from a given amount that I made, what was used to make that? We need to figure out what is species A, and if that is in grams or moles, and what is species B, and if that is in grams or moles. What do we want? So first of all, it says that we need to end up with 10 moles of water. A number of moles of butane, C4H10, will make a certain amount of water. So this is the problem we need. If I write our map that we had previously, we go from grams to moles of one species, and from moles to grams of the other species. Here, we're just converting between the moles here. So this is all our map is concerned with. And we can see here that 10 moles of water, right, which is shown in the equation. Well, to make 10 moles of water, you need 2 moles of butane to do so. So the answer to this question is that you need 2 moles of butane to make 10 moles of water. It's just seeing the relationships between these. Or you can also write a proportion. So from the equation, you know that 2 moles of butane makes 10 moles of water. And then we're just going to write a proportion so we can cross multiply. And then you have here, you keep water on the right side. And in the question we wanted 10 moles of water. So 10 moles of water. And before we knew it was 2, we had an unknown number of moles of butane made 10 moles of water. So if we cross multiply now, we have 10x just equal to 2 times 10, which is 20. And so solving for x, if we divide both sides by 10, we get that x equals 10. And we know that that's going to be in moles of water. Alright, so here we have that we need to find the moles of carbon dioxide made from 15 moles of oxygen and excess butane. Excess butane just means that we have an excess of it, meaning we have more than enough. So we don't really need to worry about that. This is not a limiting reagent problem. Okay, anyway, here. So we do the same process. What are we going to be dealing with? Well, we're going to be dealing with carbon dioxide. And we're going to be dealing with oxygen. So here we have oxygen and here we have carbon dioxide. We know that we have in the question 15 moles of oxygen, and we want to make some number of moles of carbon dioxide. Okay, so according to our map, we're only dealing with the moles. So moles of oxygen and moles of carbon dioxide. And so here we can write another proportion. First of all, let's find out what we do know. We know that 13 moles of oxygen can make 8 moles of carbon dioxide if there is excess butane, which in this case there is. Okay? Or if there's 2 moles of butane, we just need at least 2. We have here, we know that the relationship is 13 moles of oxygen will give us 8 moles of carbon dioxide. Now on the bottom, we keep carbon dioxide to the right side and oxygen to the left side. What we want to figure out is that we know we have 15 moles of oxygen gas, but we don't really know how many moles of carbon dioxide that will make. Now here is a proportion, so we can cross multiply. 13 times x is going to give us 13x, and that will be equal to 8 times 15. Which is 120. Now solving for x here, if we divide both sides by 13, we come out with x will equal 9.23. That's rounded to the second digit after the decimal point. And so we know that this will be in terms of moles of carbon dioxide. In conclusion, this means that from 15 moles of oxygen, we can make 9.23 moles of carbon dioxide. And just to make sure we're clear here, when I write the proportion, right, anytime we have 2 fractions with an equal sign in between them, we can cross multiply, as long as we keep our units straight. Meaning, if I decide to put carbon dioxide on the right side, I need to keep it on that right side. And I can't mix them up, so I can't put carbon dioxide here on the right, but then put it on the left on the denominator. They all have to stay on the same side. Another way you can write this is that you can keep everything on the top. So if you want carbon dioxide on the top, then you just keep it on the top, like this. We had 8 moles of, well, we know it's CO2 in moles. And then we have X moles of CO2. And then you would just keep that aligned. So In this case, on the left side, you're using what you know, which means you need to keep what you know on the left side. Is that what you know is 13 moles of O2. On the other side is your new one, so 15 moles of oxygen gas. You can also write it like this and cross multiply. It gives you the same thing, because all you're going to do is you're going to do 13 times x, and then you're also going to do 15 times 8. It's the same thing. Okay, so we wrote our proportion and we figured out that this is going to be our answer. Okay, here we have what is the amount in moles of oxygen needed to make 10 moles of water. Okay, so I can write our little map here. And now we figure out what we're working with. We're working with oxygen and we're working with water. Okay, so these two things. Now we see here that what we know is that 13 moles of oxygen gas will give us 10 moles of water. And writing our proportion here, we're going to keep water to the right side and oxygen to the left side. Now we deal with what the question is talking about. Here it says, what is the amount in moles of oxygen? So it's asking for moles of oxygen, which is the unknown, so we can represent unknown by just writing x. And then it's to make 10 moles of water. So we know that 10 here is the other part. And then we just cross multiply. So here we have 13 times 10, which is 130, will equal 10 times x. So 10x. And we get that x will equal 13. You get that number by dividing these two by 10. Okay, and we know that this right here is going to be in moles of oxygen gas. In conclusion, we need 13 moles of oxygen to make our 10 moles of water. Here is another example. 1.75 moles of carbon dioxide needs how many grams of butane? Okay, let's write our map for reference. Okay, so we are dealing with carbon dioxide and we are dealing with butane. Alright, now let's see what they give us. 1.75 moles of carbon dioxide needs how many grams of butane? Okay, and so we're going to need to know how many grams of this. So what is the relationship between 1.75 moles of carbon dioxide and whatever number of moles of butane? So here we see that we're going to be converting and involving grams. So if this side is going to be our carbon dioxide and this side will be our butane, then we know that we start out with moles of carbon dioxide and we're ending with grams of butane. So our map then needs to be the moles of carbon dioxide to moles of butane to grams of butane. First, we're going to convert moles to moles. So moles of carbon dioxide to moles of butane, which is going to be the same steps that we did in the two previous examples. We're going to look at what we know from the reaction, and this is a balanced equation. So we know that 8 moles of carbon dioxide is made from 2 moles of butane. And in our question, if we start out with this number of moles of carbon dioxide, we want to figure out, so we don't know, the moles of butane. Again, we have a proportion, which means we can cross multiply. 8 times x is just 8x. and then 2 times 1.75 is going to be 3.5. And if we divide both sides here by 8, we get that x will be equivalent to 0.44, rounded to the nearest hundredth. And we know that this is going to be in moles of butane. Alright, so now that we have converted moles of carbon dioxide to moles of butane, next we know that we must convert moles of butane to grams of butane. And so when we convert moles to grams, we involve the molar mass, or formula mass, whichever term you prefer. And so we know that we need to convert 0.44 moles of butane to grams of this compound. Let's first find the formula mass for butane. And that will be, let's see, carbon is going to be 12.01 grams per mole, and hydrogen is 1.01 grams per mole. These values are from the periodic table. However, we know that we have 4 carbons. So if one carbon is just 12.01 grams per mole, we know that 4 of them means that we have to multiply this number by 4. And we have 10 hydrogens, which means if one of them weighs 1.01 grams per mole, then 10 of them must be 10 times that amount. And we add these up for molar mass. So 58.14 grams per mole is going to be the molar mass for butane. So this is just saying that in 1 mole of butane, we have 58.14 grams. And so in this case here, I'm going to be placing grams on the right side and keeping moles on the left side. So if I do that, then I can solve my question according to this here. And what I have is that I have 0.44 moles of butane. So moles, I said it's going to be on the left side. And I said grams is going to be on the right. We know that grams is the unknown value, which I will be calling x. If I make some room here, I can cross multiply. So 1 times x is just x. And 58.14 times 0.44 is our other cross multiplication, which gives us 25.58. And we know that this is going to be in grams of butane. In conclusion, we have that 25.58 grams of butane is needed to make 1.75 moles of carbon dioxide. Here we have another question. 5 grams of oxygen makes how many moles of carbon dioxide? We know we are dealing with oxygen and carbon dioxide. I will draw our little map here. Grams of one substance to moles of the same substance, to moles of another substance, 2 grams of that. Now let's see what we need to figure out. They're saying that we have 5 grams of oxygen will make some number of moles of carbon dioxide. So looking at our map here, if we consider the left side to be oxygen and the right side to be carbon dioxide, Looking at our little map here, we know that we're starting at grams of oxygen and we're ending with moles of carbon dioxide. So our map is going to look like grams of O2, 2 moles of O2, 2 moles of carbon dioxide. So first we're going to convert 5 grams of oxygen to moles of oxygen. That's what our little map says here. And we know that when we convert between grams and moles, or moles to grams, we need to use the molar mass. So let's find the molar mass of oxygen gas. So 1 oxygen is going to weigh 16 grams per mole, but we have 2, so we multiply this by 2, meaning that O2 has 32 grams per mole. Okay, so this means that 1 mole of oxygen is 32 grams of oxygen. And so in this example, I'm keeping moles to the left and grams to the right. So here, we want to now convert grams to moles of oxygen. So 5 grams of oxygen. So if grams are on the right, that's where I'll put the 5 on the bottom. We know that that equals a certain amount of moles, the unknown for oxygen. Now we can cross multiply here. So 32 times x is going to be 32x, which is going to be equal to 5 times 1, which is just 5. Solving for x by dividing both sides by 32 will give us x equal to, it's going to be 0.16. And we know that this is going to be in moles of O2. So that step is done. We have successfully converted grams of O2 to moles of O2. Now, next is moles of O2 to moles of CO2. So now we need to convert 0.16 moles of oxygen to some number of moles of carbon dioxide. So we do the same steps. So looking at these two, we know that 13 moles of oxygen can make 8 moles of CO2. And this is in moles, the 13. Okay. And so here we have oxygen on the left side. So on the bottom will be our conversion, which is 0.16 moles of oxygen is some number, we'll just call that x because it's unknown, moles of carbon dioxide, which means we can cross multiply as we have another proportion. So 13 times x is going to be 13x, and is going to be equal to 8 times 0.16, which is 1.28. Dividing both sides by 13, we get that x will equal 0.098. And we know that will be in moles of CO2. And so we have completed this step over here. In conclusion for this question, we know that 5 grams of oxygen will make 0.098 moles of carbon dioxide. 100 grams of water needs some moles of oxygen and some moles of butane. Okay, so basically here we have almost 2 questions. They're asking how many moles of oxygen and how many moles of butane do we need to make 100 grams of water. So let's first deal with this part of the question. So 100 grams of water needs some number of moles of oxygen. So let's write our little map here. So for this, we can put water on the left side and oxygen on the right side. We know that we start out with grams of water, and we need to convert that to moles of oxygen. So let's convert. Let's see the stoichiometric relationship between 100 grams of water and some number of moles of oxygen. This is our first step. 100 grams of water will equal some number of moles of oxygen. And so seeing as we have here grams to moles to moles to grams, we see here that we start with grams of water and we need to convert to moles of water next. That's our intermediate step. We need to involve the molar mass. The molar mass of water is going to be about 18.02 grams per mole. So we know that in 1 mole we have 18.02 grams of water, and in some number of moles of water we have 100 grams of water. Now we can cross multiply. 18 times x is going to be 18x, and 100 times 1 is just 100. Dividing both sides by 18, we get that x is going to be equal to 5.56, and that will be in moles of water. So now we have completed that first step right here. Now we need to convert moles of water to moles of oxygen. And to do that, we use the stoichiometric coefficients to tell us the relationship between water and oxygen. We know here that 10 moles of water is made from 13 moles of O2, and we know that in the new question we have 5.56 moles of water needed to be converted into some moles of oxygen. We cross multiply. So here 10 times x is going to be 10x, and 13 times 5.56 is going to be equal to 72.28. If we divide both sides by 10, we come out with x equal to 7.23, and that will be in moles of O2. So we know that 7.23 moles of oxygen are needed to make 100 grams of water. And now we have the second part of the question, where it asks 100 grams of water needs some number of moles of butane. So for the next part, 100 grams of water needs some number of moles of butane. Now we already know that 100 grams of water is equal to 5.56 moles of water. So now we just need to convert this into moles of butane. And see how many moles of that we need. And so when we look at the balanced equation, we can see that relationship. We know that 10 moles of water needs 2 moles of butane. And on the bottom we will put what we want to know. So if I put water on the left side, I keep it to the left side. So this new number will go down here. 5.56 moles of water will need some number of moles of butane. I can cross multiply because I have a proportion. 2 times 5.56 is equal to 11.12. and 10 times x is just 10x. Dividing both sides by 10 will give us that x is equal to 1.11, and that we know will be in moles of butane. So in the end, we can complete our sentence here. 100 grams of water needs 7.23 moles of oxygen and 1.11 moles of butane. 250 grams of butane makes some number of grams of water. So I'll write our map here again. Here we are dealing with water and butane. So we know that we need to convert 250 grams of butane to grams of water. Okay, so let's see the relationship here. We are starting with grams of butane, and we need to go to grams of water. So we're going to be doing this whole map here. So from grams of butane to moles of butane, from moles of butane to moles of water, and finally from moles of water to grams of water. Let's first convert grams to moles of 250 grams of butane. First, we know that for butane, the molar mass is going to be 58.14 grams per mole. So that means that there are 58.14 grams of butane. Just put a note here for ourselves that we're dealing with butane at this point, is equal to 1 mole of butane. And on the bottom we have, well, we know that we have 250 grams of it, and we want to convert that to some number of moles. Cross multiplying, we have 58.14x is equal to 250. That's by cross multiplication. And so dividing both sides by 58.14, we get that x has to be equal to 4.3. And we know that's going to be in moles. Our next step is to see the stoichiometric relationship between 4.3 moles of butane and the number of moles of water. So from the equation, we see here that 2 moles of C4H10 can make 10 moles of water. Okay, and I'm going to write my proportion here. So if I have butane on the left side, I will keep it there. If I have 4.3 moles of butane, then I have some number of moles of water. Cross multiplying equals 2x equals 43. X must be equal to 21.5. We know that's going to be in moles of water. So far, we have converted grams of butane to moles of water. Our next step is to convert moles of water to grams of water. In order to do that, then we use the molar mass of water, which we know is going to be equal to 18.02. So in order to convert moles of water to grams of water, we use the molar mass of it, which is going to be 18.02 grams per mole. This means that we have 18.02 grams of water in 1 mole of water. We're talking about water here. And on the bottom will be our question here. But we want to convert this many moles to a certain number of grams of water. So keeping grams on the left side, I have x grams. And on the right side, I have a number of moles here that I want to know. Okay, cross multiplying equals x is equal to 18.02 times 21.5, which gives us 387.43. We know that's going to be grams of water. So in the end, we know that 250 grams of butane will make 387.43 grams of water. So basically, stoichiometry is just about seeing the relationships between the different reactants and products. And when you use the relationship in the balanced equation, that is when you're converting moles of one substance to moles of another substance. And when you're converting grams to moles or moles to grams of one substance, you need to involve the molar mass, which can be found from the atomic masses from the periodic table, and summing those numbers up based on the number of elements in each compound. Thank you so much for watching this video. I really hope you enjoyed it. If you did, don't forget to subscribe and leave a comment down below. Also, remember that I offer online tutoring, so check out the description for that. I'll see you next time.